How do you give directions to someone? You basically tell him where that place is and how far that place is. Therefore, you require two things when giving directions: distance and where it is. So, showing directions and giving the distance constitute a vector. This is one way to imagine a vector. In maths, there are three ways to represent a vector. Firstly, we use letters such as small a with a curly line below it, or capital AB, where A is a starting point and B is an ending point. The second way is by drawing directed lines in a coordinate system. Okay, your familiar XY axis. And thirdly is by using a 2x1 column matrix. Now let's look at the first one, which is using letters to name a vector. It's either we use small letters with curly lines below it, or we use capital letters. For capital letters, we write two letters. In this case, AB. The first letter is always the starting point, and the second letter the ending point. And the arrow is always pointed to the right. Please note that the vector written in red is not possible because the arrow always points to the right from the starting point to the ending point. Next, how do we draw vectors? We draw them as directed lines in your familiar XY axis. Okay, we need 2 points, in this case AB, where A is a starting point and B is an ending point. And when you draw a line through them, the arrow must always point from the starting point to the ending point. And on the right, we have the vector CD, where C is the starting point and D is the ending point. Note that a vector can also be named using small letter with a curly line below it, as seen here. Now, the starting point and the ending point is not shown, but you should always know that the arrow always point from the starting point to the ending point. So, the starting point is on the left and the ending point is on the right. Next, we can represent vectors using a 2x1 column matrix. So, how do we find the elements of this matrix? Look at the vector here. The vector is AB, where A is the starting point and B is the end point. Starting from A, I move in the X direction. Either I move right or I move left. In this case, I move right to get to B, and I move 9 units. After I reach directly below B, I go up 3 units. Therefore, these numbers 9 and 3, I put it inside a matrix. Therefore, if I use a matrix to represent a vector, the top number represents how many steps I move in the X direction from the starting point, and the bottom number represents how many steps I move in the Y direction. Notice that I use the words positive X direction and positive Y direction. Why is that so? Let's take a look at this vector CD. Notice that from the starting point C, I move 6 units to the left and then 5 units down. The matrix representation of this vector is -6 and -5. Therefore, when you move in the negative X direction, there must be a negative sign. And when you move in the negative Y direction, there must be a negative sign. That's how you differentiate between up and down, left and right. So, if I'm given the matrix of the vector AB, I know how to go from A to B. Now remember, a vector is all about giving direction as well as the distance. So how do we find the distance of AB? Notice that I can construct a right angle triangle using the vector AB. The the 12 is the base of the right angle triangle, and the 3 is the height of the right angle triangle. And what do we always use when we want to find an unknown side of a right angle triangle? We use Pythagoras theorem. Therefore, the length of any vector is simply labeled as the vector inside two vertical lines as shown here. And to find the value, we simply use Pythagoras theorem. In this case, the square root of 12 square plus 3 square. So, if I have the matrix of a vector and I want to find the length of this vector, I simply name it as the vector inside two parallel lines, and the value is simply taking the square of each element of the matrix and then I add them up and then take a square root as shown here. Another example is the vector m. So to find the length of this vector m, I simply do as follows. Now let us summarize. A vector is simply giving direction and distance to somebody. And a vector can be named either by using small letters with curly lines below it, or by two capital letters, where the first letter is a starting point and the second letter is the ending point, and the arrow on top of them always point to the right. Or a vector can be represented as a matrix. And lastly, how do we find the length or the magnitude of the vector? We simply use Pythagoras theorem and take the square root of the square of each term of the matrix. Now, let us take a look at this concept of equal vectors. Observe the two vectors here, AB and CD. Do you think they are equal? If you think they are equal, why? What are the properties that make them equal? If you were to write out the matrix of each vector, you will see that they both have the same matrix elements. Therefore, they are equal. So, two vectors are equal if they have the same matrix. How do we picture equal vectors? One way is from the following drawing. You can imagine two different people giving the same direction and distance. Let's look at one example. If I'm given the vectors A and B, and I know that they are equal, therefore Q must be 1 and P must be 3. Now, let us go into addition of vectors. You can imagine the addition of vectors as somebody giving many directions. Let us study this more deeply. Imagine you have the following vectors: from home to library, from library to shop, and from shop to restaurant. If you were to add all these vectors, what is the representation for the sum of vectors? The sum of vectors is simply a vector drawn from where you started to where you end up at the end, which is depicted by the red line here. So, if you started from A and you go through many vectors to finally get to point B, the sum of all these vectors is simply the vector drawn from A to B. Let us take a look at this in more detail now. Given two vectors AB and BC, and I were to add them up, we know that the addition of vectors will simply produce a vector that starts from the starting point A and points towards the ending point C, which is AC. Now, if I were to write this out, AB plus BC equals to AC, what do you see? You notice that the endpoint of the first vector AB is the same as the starting point of the second vector BC. Now, if I have two vectors AQ and QB and I were to add them up, I will get AB. The reason is the same as before. The endpoint of the first vector AQ is the same as the starting point of the second vector QB. If I were to extend this further, I will get AF. Please take a moment to understand this. Now, how do we add vectors using the matrices? Let's observe the following diagram. I have AB and I add it to BC. We know it will produce the vector AC. Since this is addition of vectors, we simply add the matrices as shown here. Let us now return to our familiar x and y axis. Now I have two vectors P and Q. How do I draw the addition of P and Q? One method is called the triangular method. First, I draw one vector first of your own choice. For me, I choose to draw P first. Next, I draw the second vector from the endpoint of the first vector which I drew. Lastly, I draw a line to complete the triangle. And my direction is from the starting point of P to the ending point of Q. Now, the new vector is always represented by double arrows. Is P plus Q the same as Q plus P? The answer is yes. If you were to draw it, you will get the same vector pointing in the same direction and having the same length. Now, let us take a look at the second method, which is called the parallelogram method. First, draw a vector of your own choice. For me, I start with vector P. Next, I draw the second vector from the starting point of the first vector. Lastly, you complete the parallelogram, which means you draw another vector P and another vector Q. And the vector P plus Q is simply the diagonal of the parallelogram, which is drawn in red here. Now, the diagonal line is drawn from the starting point where you draw P and Q. To summarize, if I have the vector C and D and I want to add them, this is my result. On the left is the triangular method and on the right is the parallelogram method. Now, if there are vector addition, there has to be vector subtraction. Before we go to vector subtraction, let's study the following. I have 2 points A and B. Now, AB is 6, 3 if you have been paying close attention. My question is, what is BA? Now, the vector BA, the starting point is B and the ending point is A. So, it should be -6 and -3. So, what is the relationship between AB and BA? If AB is 6, 3, then as you have observed, BA is -6, -3, which is simply the negative of AB. So, if I have PQ and I want to find QP, then QP is simply negative of PQ. So, the rearranging of letters must be accompanied by a negative sign. If you were to observe carefully, you will notice that AB and BA, they are the same vector but pointing in opposite directions. Therefore, the negative sign simply means that it is pointing in the opposite direction. Let us now apply to the following question. AB minus CB. Now, I did not teach you how to minus vectors, but look at the second line. AB minus CB is the same as AB plus the negative of CB. Remember that plus meets minus to give you minus. And then we get AB plus BC. Okay, from previous slides, negative CB is the same as BC. And now look at AB plus BC. The second letter of the first vector is the same as the first letter of the second vector. As you have learned previously, this will give us AC. Let us summarize. If I know the vector AB and I want to find the vector BA, they are simply the negative of each other. The negative sign simply means it is pointing in the opposite direction. How do we apply this? If I'm doing PQ minus RQ, I can convert negative RQ into positive QR. We do this because we have learned how to add vectors. Now, how do we compute the subtraction of vectors using matrices? If I want to find P minus Q here, I simply subtract the two matrices. Now, how do we draw the subtraction of vectors? Now, we apply what we have already learned. P minus Q is the same as P plus the negative of Q. Now recall, how does negative Q look like? Minus Q is the same as Q, but it is pointing in the opposite direction as shown by the blue vector here. So right now, I want to add the vector P and the blue vector negative Q. I will teach you the triangular law, which you have already learned previously. So the first step, I draw a vector first. I choose to draw vector P first. Next, I draw the vector minus Q at the end point of the first vector. And lastly, we complete the triangle. So the vector P minus Q or P plus the negative of Q is simply the red color vector drawn from the starting point of P and the ending point of negative Q. I hope vector subtraction is not difficult. It is very similar to vector addition. So if I have vector P and I want to find the negative P, the vector negative P is just the same as vector P but pointing in the opposite direction. Same goes for point number 2. If I know AB, I want to find BA is just the negative of each other. Therefore, in vectors, the negative sign simply means it is pointing in the opposite direction. Now, how do we apply this? Look at point number 3. If I want to compute the subtraction of many vectors, I can change the subtraction into addition by applying point number 2. So, why do we want to change from minus to plus? It is because we have already learned vector addition and they are very simple. And lastly, how do we draw the subtraction of vectors? We just use back the triangular law which you have already learned for vector addition. So, P minus Q, you just change it into P plus negative of Q. And negative of Q is just the same as Q but pointing in the opposite direction. So just apply what you have learned for triangular law. Start with vector P and then you draw negative Q at the end point of P and you complete the triangle. If you have understood the lesson so far, please do the following worksheet which are given to you in class.